Is mass timber the newest and latest way to help build housing to help decarbonize? Join us in this session and you can learn a little bit more as we go. Now, before we get started, we did want to let you all know that we are onboarding new board members here at the Green Home Institute. So you can check it out on our website under Get Involved and look at possibly joining the board or some of our different committees. We're looking at especially engaged webinar attendees who are attending our sessions and know a little bit about us to join us and help us progress our mission. So we hope you will consider that. And before we get started, also, we want to say a thanks to one of our top tier sponsors, Build Equinox. Traditional ERVs and HRVs provide basic ventilation, but often lack protection against airborne threats like seasonal flu and wildfire smoke. Introducing the SERV, an advanced indoor air quality management system, it offers energy recovery ventilation with enhanced protection and intelligent air management. It does this through continuously monitoring pollutants in the air like CO2 and VOC levels and ensuring fresh air is only brought in when pollutants exceed healthy thresholds, thus saving energy compared to traditional ventilation systems. It features a high-efficiency heat pump that recovers energy from exhausted air, preconditioning and potentially dehumidifying incoming air to increase comfort. It has a recirculation mode when you don't need that ventilation, optional UV filtration, and sensors to protect against harmful outdoor air like wildfire smoke. So check out buildequinox.com to learn more. All right, welcome everyone to Mass Timber, an introduction and examples of low carbon housing. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here at the Green Home Institute. Like all of our courses, this one is approved for multiple continuing education units. It's 3 pillars in our Certified Green Home Professional designation: place, energy, and materials. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. Check out that 5-digit passive house code that will come at the end within your certificate. And brand new, we're grateful for connection with the Energy Smart Institute as a preferred education provider to offer the International Cold or ICC certificate CEUs as well. You'll receive that 5-digit code for that as well within your certificate. So with that, I am excited to hand this over to our speakers today. We will have them in order of Sandra first, and then Anthony Harvey with Woodworks coming second. But so Sandra with Michigan State University, welcome. Please take it away.
Well, thank you so much, Brett. I will get started as soon as I can share my screen here. Looks like I just got permission to do that. So let me get that up for everybody real quick. And of course, everybody's going to tell me when they can see just the slides. Which, is that now or do I need to switch?
One more,
Right?
yep.
You got it. All right, so now we should be good to go. Well, hello, everybody, and thanks so much to Brett and the Green Home Institute for hosting this conversation today on my favorite topic, and I think my colleague Anthony Harvey's favorite topic, mass timber. I'm going to talk to you a bit about, provide you with an overview of what is mass timber, what are some of the things we're so excited about regarding mass timber, and then I'll focus a little bit on kind of in a nutshell, what's happening here in Michigan. And hopefully that will have relevance to the folks throughout the Great Lakes region and across the United States who are part of this conversation today. So first of all, our program, Mass Timber at MSU, we are a collaboration across our Department of Forestry, the School of Planning, Design, and Construction, and MSU Extension being the outreach and stakeholder engagement wing of a land-grant university. And we're focused on advancing mass timber construction and manufacture across Michigan, the Great Lakes region, and beyond by conducting research, education, outreach, stakeholder engagement, and communications, as well as thinking about policy. And one of the key reasons that we have this program at MSU It has to do with the broad benefits of mass timber, and also our state, Michigan, especially the Michigan Department of Natural Resources, is very interested in seeing mass timber production begin to take place in Michigan. So lots of good reasons to be advancing mass timber, and this is how we're doing it. What even is mass timber? I know it's like some of you will be very familiar with it. Some of you might be think you are like, oh, I think I know what that is, and some might not have any knowledge at all. So level setting, when I say mass timber, I'm using an umbrella term to refer to a variety of really big engineered wood building construction materials that we're typically thinking about using in larger buildings, commercial buildings, multifamily, etc., because of their large size, in ways that we would typically use steel or concrete, either alone or in hybrid structures with those same materials, to provide a variety of different structural benefits as well as non-structural benefits. So big and engineered wood, those are your keywords. A few different types of mass timber. Glue laminated timber, these are columns and beams, and you've probably seen these throughout your life in a variety of different types of structures, maybe a custom home, for example, or a church. These are made by putting together layers of dimensional lumber with adhesive and then pressed in a big hydraulic press to create a column or beam that's very, very strong and very, very stiff. And when we talk about glulam in the context of mass timber, we're talking about really, really big ones, basically. Cross-laminated timber. Like glue laminated timber, it comprises layers of dimensional lumber. Here, though, the shape is usually that of a large panel as opposed to a column or beam, and each layer of wood is in the opposite layer or the opposite direction of the one next to it, right? So we're creating something here that is strong in more than one direction. It can handle gravity, but it can also provide the lateral resistance in a building, which is something we haven't been able to do with wood in tall buildings in the past. So cross-laminated timber is really the mass timber typology that I would say has helped to coin the term mass timber. So glue laminated timber, cross laminated timber, these are the two most common types of mass timber. We also have mass plywood panels that are layers of plywood sheets put together to make a gigantic panel. Nail laminated timber, this is a type of mass timber that's been around for a long time. No adhesive here, instead we use nails to laminate the members together. Dowel laminated timber uses wooden dowels, and then laminated veneer lumber is another type of mass timber, but really glulam and CLT are the most kind of common and important types at this stage. So just it helps to visualize the mass timber production cycle, I think, as we're starting to learn about mass timber. Of course, it starts in the forests. It starts with healthy, resilient forests is always the goal and the priority here. We do harvest trees from the forest to create lumber that is then milled into dimensional lumber that is dried in a kiln and then moved into a manufacturing facility to create those columns or panels and beams through manufacturing processes. Then with mass timber, and this is really important because mass timber is typically delivered to your project site as a prefabricated kit of parts. The manufactured columns and panels and beams move into a fabrication cycle. Sometimes this is vertically integrated into the same manufacturing business. Sometimes it's a separate company, it depends. But what's important here, right, is that here we're using computerized technology, we're using CNC machines, we're using gigantic drills to make sure that every column and panel and beam is cut to exactly the right dimensions it needs to be on the building site. Openings for doors and windows are already cut out when everything arrives, and holes and openings for connecting hardware are drilled in exactly the right places. And then here we're also attaching oftentimes metal connectors into the mass timber columns and panels and beams in the factory, so that when everything arrives on the construction site here, it goes up pretty efficiently and quickly. Sometimes people call it like Legos or Legos on steroids or like an erector set. So just a real quick history of mass timber momentum in the United States, and then I'll get into what's happening in Michigan, but I'm going to do this fast because we're not going to spend a lot of time on this. But mass timber is pretty new in the United States. And of course, in the overall context, historical context of building construction, super new in general. But before the 1980s, we had glue laminated timber, we had nail laminated timber. in our building construction codes for a number of decades. In the 1980s, in Europe, cross-laminated timber panels emerged commercially. The first kind of patented cross-laminated timber type technology happened about 100 years ago, but in the 1980s, it started being commercialized, especially in Austria and Germany. Then in the 2010s, here in the United States, people started hearing about all these benefits of mass timber and thinking about how can we begin to implement that here. In 2015, we had the first cross-laminated timber panels made in the United States in Oregon. Then in 2016, there was an important milestone where the first International Mass Timber Conference was held. There were enough people who were starting to be excited about mass timber that they decided to come together and start to create a supportive professional community. That same year, we saw the first tall mass timber high-rise completed in the US, about 7 stories. This is a project in Minnesota, so for the Minnesota folks on the call, good job, you went first. Then we saw the first building in the US completed using that domestically produced cross-laminated timber in 2016. This building was also in Oregon. In Oregon again in 2018, we saw the first multi-family mass timber high-rise completed. This one's called Carbon 12. It's 8 stories in Portland, Oregon. And then in 2022, the tallest mass timber building in the world was completed. Again, here in the Great Lakes region in Milwaukee, this is the Ascent Tower. It's 18 stories of mass timber over a 7-story concrete podium, and it is a multifamily housing structure. So we've seen momentum kind of growing pretty quickly here in the US with demand, and I know Anthony's going to have a more updated version, I think, of this slide, but with demand more than quintupling between 2018 and June of 2024 all over the country. And this represents a whole bunch of different types of buildings that have been either completed or in various stages of design, development, or construction. So momentum is growing. People are interested in mass timber. And now we're going to talk a little bit about why. Why are people looking to build mass timber buildings now in the United States? First, there's this term called biophilia, right? The idea that when we live in buildings that are made of mass timber, when we work or study or play in buildings that are made of mass timber, it's good for us. We like it. You know, we all kind of have a natural response to being in a building where there's a lot of exposed wood. We know we feel good. We don't know usually that word for that is biophilia, but there has been research showing that when we are in buildings like that, we might have lower stress, we might have an improved sense of well-being, increased productivity, just a generally good, it's a good vibe, but there's more to it than just a good vibe. So we are seeing people choosing mass timber for this reason. We're drawn to it. Certainly of interest to this group, and certainly why I became interested in mass timber, is the ability to reduce the embodied carbon footprint of buildings, reducing the overall carbon footprint of our built environments. This pie chart is one that I guarantee is familiar to everyone on this call, so I'm not even going to cover it in any real way, but just note that, you know, this 11% of global greenhouse gas emissions in 2015 is attributable to the construction industry, and that's materials, right? This is the materials, this is the embodied carbon, and this is what we can start to address with mass timber. And we can quantify those benefits. This study came from the U.S. Forest Service Wood Products Lab in Madison, Wisconsin. It was released in 2024. And what they did was they conducted, or they modeled, a whole building life cycle analysis looking at cradle to grave, looking at identical kind of buildings based on the 2021 International Building Code, and then comparing the global warming potential of reinforced concrete versus structural steel versus mass timber. And now if you look at this graphic here, I think it's probably a little bit hard for you to see if you're on a small screen, but everything in blue is what was included in the model. And that's all of the embodied carbon, the materials, sourcing, transporting, manufacturing, getting it to the site, installing it, then maintaining and replacing materials once they're in the building. Then demolishing, transporting, processing waste and disposal, and then thinking about what happens to the materials when they're no longer in that building. What's the next life of those materials? That's all included in the model. What's not included in the model is the operational carbon, which is generally considered a wash from between these building types, but the embodied carbon is all here. So when we look at just that embodied carbon, savings, we see that the global warming potential of mass timber versus concrete is 39 to 51% lower. Okay, so that's pretty impressive already. But then when we start to think about stored carbon, the results become even more dramatic. Of course, just like reminding us all that wood stores carbon because trees absorb carbon dioxide from the atmosphere, they convert it to carbon, they store it in their trunks and branches in the soil. And then when we harvest a tree, what happens, of course, is that much of that carbon is retained in the wood. Wood is 50% carbon by dry weight. So a lot of carbon is locked up in wood. And just noting that, and I can't go into a large treatise on forest management here, but very important to note that in the United States, our forests almost across the board in the United States have more trees per acre than is considered a healthy forest density, which creates a lot of vulnerability on forests to things like high severity wildfires, pest infestation, etc. So there is a strong need to reduce the density of our forests in most parts of the United States in order to avoid losing the carbon that's stored in those trees to fire and to mortality caused by pests. Obviously, ensuring that we're doing that in a sustainable way, that we're regenerating forest, and that forest health and resilience is always at the top of the list of priorities is critical. But it is very important that we're interacting with forests in this stewardship manner and that we're using the wood resulting from that stewardship to create products that benefit us, and particularly products that store carbon for a really long time, like mass timber. So when we start adding in that stored carbon with the embodied carbon, then the global warming potential of mass timber versus concrete becomes 81 to 94% lower, according to the study. And for steel, it's a little bit less dramatic, but 76 to 91% lower. So you can start to imagine how if we're building more buildings using mass timber and reducing the amount of other materials that we're using, we can start to create significantly lower carbon footprints in our built environments. In addition to those benefits, of course, we can create new jobs and economic benefits to our communities, whether that's revenue for forest landowners to reinvest in managing their forests, whether it's revitalizing our forestry and forest products sector, which have been on the decline in the Great Lakes region and Michigan for many decades, or it's creating new types of jobs in mass timber production, or even new types of construction jobs. There are benefits to be enjoyed there. And then from a design and engineering perspective, we need to remember that mass timber is a high performance material. And again, we're not comparing it to stick framing. We're comparing it to commercial construction, to things like steel and concrete. And when we do that, we know that mass timber is lighter weight, but very strong. So it has a great strength to weight ratio, works well in hybrid systems or on its own, performs really well in seismic testing where that's relevant, and is extremely has extremely excellent fire resistance properties. Important to think about mass timber as a material in which the fire resistance is designed into the material. So you design the thickness and the density of your columns and panels and beams to ensure that you have enough material such that so that the exterior will char if there's a fire, and then the structural layers within would remain intact. So kind of like if you throw a whole log into a campfire and you try to get it to burn, it doesn't, right? The outside chars, the inside doesn't burn, and that's what we see with mass timber, and you can see the results of a fire test here on the lower right corner. In addition, right, mass timber is a prefabricated system, which I mentioned, and it does arrive on site ready to assemble, so that can save you significant time. It can save the need to, because it's fire resistant and beautiful, it can save on the need to cover with aesthetic or fire coatings. And of course, you don't need as many people to put it together because of this prefabricated system. And then finally, owners, developers and building owners are seeing benefits as well. And this is actually some data that Woodworks has sourced, and Anthony here on the call is very familiar with this, but owners and developers are seeing often a faster return on investment because you build faster, a higher return on investment due to that biophilic nature of the materials, the desirability, and also, of course, sustainability benefits, a reduced carbon footprint, which is wonderful in particular for corporate real estate portfolios. So lots of benefits. Now in Michigan, why the heck are we so interested in mass timber, right? Well, we've got a lot of forests here. Our state is 53% forested. We're very good at making things in Michigan, right? We've invented certain types of things that are manufactured. We make a lot of furniture here, and our forest products industry has been really important both to our economy and to our culture for many, many, many decades, and continues to be important. We need to build. We all know we need to build. In Michigan, we have a 190,000 housing unit deficit and plenty of other types of buildings that we need to build, whether they're institutional, commercial, and all different types of buildings that lend themselves well to mass timber. And we also have policy direction that tells us that mass timber is a good fit for Michigan. Our Michigan Healthy Climate Plan, the state's roadmap to achieving net zero carbon by 2050, mentions mass timber 3 times as a tool in the state's toolkit to getting there, both in terms of building construction and strategies on natural and working lands like forests. To that end, the state has already been making investments in mass timber. The 2025 fiscal year budget included an investment of $1 million to continue to develop a mass timber economy here. The state has invested at least $750,000 in our program, Mass Timber at MSU, to conduct a lot of that work. Has invested $11 million in building its own mass timber building. The Department of Natural Resources opened its new customer services building in Newberry in Michigan's Upper Peninsula last year using mass timber, and it's actually the first building to use Michigan-sourced wood in mass timber. So the state really took a leadership role in proving that we can use Michigan red pine in cross-laminated timber. And finally, the state legislature did help to fund the STEM teaching and learning facility. This is a $100+ million building on Michigan State University's campus that houses science, technology, engineering, and mathematics courses, and was only the second building in the state to use cross-laminated timber panels when it opened in 2021. So a lot of state support and engagement in advancing mass timber. It's working, right? The work that we're doing through our program, the investments that the state is making, the kind of collective effort of practitioners and owners is resulting in increased demand for mass timber in Michigan. We now have more than 65 projects that are completed or in the pipeline statewide, and they're all different types of buildings. And you can kind of see that in the list here on the left: universities, schools, different types of training and community facilities. There's a hotel in the works. And then, of course, some apartments and condos that have been in design or have already been completed, including some attainable housing here in the Traverse City area made by Homestretch Housing. So lots of demand all across the state and across a variety of typologies. And here's just a few examples of those buildings. Here's some more pictures of our STEM teaching and learning facility. This is a hybrid structure. It uses glue laminated timber, cross laminated timber here in the floor decks, and then there is a lot of steel involved as well, including these cross braces, which contribute to the lateral resistance for this building. This opened in July of 2021. This is a community center in Detroit that uses cross-laminated timber in the roof, and then some glue laminated timber elsewhere. The mass timber came into this project because the community identified it wanted a connection to nature and kind of Michigan forests as part of the design of this building. This veterinary hospital in Westland probably has the happiest animal clients, you know, in the state. Beautiful glue laminated timber and cross laminated timber here. And then this is a project in Muskegon, Adelaide Point, with multiple mass timber developments on one site, including these condominiums, a event and restaurant facility, and then this is the site where they're also working on a hotel. And then here's that attainable housing development that I mentioned in Sutton's Bay, done by Homestretch Housing. It's a hybrid structural system with cross-laminated timber floor panels, and then some stick framing. So it's hybrid, and this model was really well thought out and researched by the developer, and they've been working to create this as a model and replicate it elsewhere. So those are just some examples of the many mass timber projects that are in development here in Michigan. And now what I'd like to do briefly is share some ways that you can engage with Mass Timber at MSU and our partners in Michigan if you're a mass timber, if you're somebody who's actively engaging in or exploring mass timber in our state. We host the Michigan Mass Timber Community of Practice, a virtual quarterly gathering where we provide technical assistance to people across the mass timber value chain, whether they're starting to think about manufacturing mass timber, they're developing mass timber buildings, they're thinking about mass timber workforce. We co-host this with Woodworks and the American Wood Council. And if you're interested in joining this community and you're involved in mass timber in Michigan, you're welcome to scan this QR code and fill out the form. In December, we host the Michigan Mass Timber Update for folks who are engaged in mass timber in Michigan. This is our annual celebration of mass timber momentum here. This year it's going to be December 3rd in Kalamazoo, Michigan, and on a site where there's a new mass timber building at the Kalamazoo Country Club. And the day before, Woodworks will host a workshop also in Kalamazoo, Michigan. If you're interested in this, please feel free to email me and let me know you'd like an invitation. My email will appear in the contacts at the end of the presentation. And then we're about to launch the Michigan Mass Timber Catalyst Fund. This is funded by some of that $1 million investment from the 2015 or the 2025 Michigan state budget. And it's a program by the Department of Natural Resources Office of Public Lands, produced in collaboration by us, Mass Timber at MSU, Woodworks, and the Michigan Green Building Collaborative. Here we're looking to offset what we call the real or perceived green premium associated with being an early adopter of mass timber. Oftentimes we're seeing people thinking mass timber is going to cost more and shying away from it, or seeing materials estimates that might be a little bit more. This is meant to help them offset that, but also to understand a strategy to moving forward with their mass timber building. We're going to provide small grants for projects based on their project size and various factors. Plus, the people who are selected, the projects that are selected, will participate in a year-long technical assistance cohort. We're going to be prioritizing certain benefits and types of projects, including affordable and attainable housing, some others as well. And here we really want to remove barriers to early adopters of mass timber in Michigan. So we're very excited about this. We expect to launch an RFP for this sometime in the fall. Outside of Michigan, because I know we have a lot of folks in the Great Lakes region on this call and across the country, there is significantly rapidly growing demand for mass timber across the Great Lakes region. Here you can see across 8 Great Lakes states that we have at least 346 projects in the pipeline, according to Woodworks, and this is really significant and exciting. And finally, Mass Timber at MSU with Bedrock, the real estate developer based in Detroit, has been convening what we're calling the Great Lakes Mass Timber Collaborative. And we are about to publish a regional vision that has resulted from numerous meetings by people across 7 Great Lakes states. And there's a lot of opportunity for people to start plugging into this as we think about how to move this forward. So if you're in the Great Lakes region and you're interested in kind of thinking about a holistic vision for a Great Lakes mass timber economy and ecosystem, please feel free to reach out to me here and I will get you plugged into the list. So that's what I have for you today. Mass timber demand is growing in Michigan. We're getting closer to realizing mass timber manufacture here in Michigan, but there's a really strong need to be also thinking about mass timber across the broader Great Lakes region. And we are here to facilitate that and support you as you move forward with all of your mass timber projects and initiatives and adventures. And now I would like to pass it off to my good friend and colleague, Anthony Harpy with Woodworks.
Yeah, thank you, Sandra. Here, we'll get my slides pulled up. You set the mouse pointer here. There we go. All right, got the laser pointer up. All right. Yeah, good afternoon, everyone. My name's Anthony Harvey. I'm a regional director with Woodworks, and just going to continue our conversation here today, talking about mass timber, and then more specifically, kind of looking just with a housing lens. Obviously, we can use mass timber for all kinds of different projects types. You saw some of those in Sandra's opening segment, whether it's office, higher education, K through 12, manufacturing, warehouses, etc. But here, through these, we'll just kind of look at multifamily or housing type situations. First, I just wanted to talk about Woodworks. Just in case you're not familiar with us, just to let you know who we are. We are a nonprofit that really focuses mainly on offering free project support to the industry. So any kind of a question that you have, feel free to reach out to us. We're happy to help. Some of the bullet points that are listed here are some of the big kind of picture topics that we deal with the most, but happy to handle all kinds of different things into the weeds. We've already been kind of looking at some of the questions that have been coming in the Q&A piece. So happy to maybe dive into some of these here live on the webinar today. We also offer education. So not only, obviously we participate in events like today, but we also have webinars on our website every month that are free to sign up for. You do get AIA credits and CEUs for those as well. And in fact, this month, or excuse me, almost this month in August, which is almost here, I'll be the presenter or one of the co-presenters for our webinar, and we'll be talking about architectural considerations in light frame, mainly construction. So feel free to take a look at that. Generally, those are on the second Wednesday of the month. And then we also have tons of different resources. I think I'll reference maybe one or two of those, but our website is full of those. So like, for example, I think someone in one of the Q&A questions that asked about VOCs and off-gassing. I believe we have an expert tip on our website that covers that. If not, I think AWC does. So we have all kinds of different resources. Some of them are PDFs, documents that go into further detail, like fire resistance ratings that I'll be talking about. But then we also have some kind of small niche things that are just on our website as well. So that's kind of Woodworks in a quick nutshell. And then also just wanted to mention, as I said, we're a free resource. So just wanted to thank all of our great funding partners. The two main funding partners being the Softwood Lumber Board and USDA Forest Service. And then we also have lots of industry partners as well. All right, so just kind of getting into the meat of the presentation here. And mass timber, is it a good fit for your multifamily project? And this project that you see here in the background, I think I saw in the chat that someone was tuning in from Milwaukee. So this is from that Ascent project, the world's tallest project right now. But the next world's tallest is currently under construction there in Milwaukee as well. So it'll have two world-breaking buildings right there in town. So that'd be really cool. So next, I just wanted to talk about multifamily mass timber. What do we see across the country so far? So this is looking at the end of the first quarter of 2025. So we put these out every quarter. So there was a Q2 report out already, but this is just kind of looking as of the end of March. You can see that we've got a little over 1,200 projects built. So this is all mass timber, all construction types, and then a little over 1,100 in design. So what's the breakdown for this in multifamily? So of this total number of projects, 540 or 22% is actually multifamily. So, almost a quarter of these are, and that's across, again, higher ed, business occupancy, all different occupancy types. So quite a bit, of these are multifamily. And then how about the scale? So just a little bit of a breakdown of numbers of stories, and then we'll have some case studies here at the very end that kind of show you visually what some of these might look at. So we can see 1 to 4 stories. We have about 27% of those, 5 to 7 stories. So kind of getting into that upper range of mid-rise is about a third. And then what we would consider tall wood, 8 stories or more, 31%. Now, what's kind of interesting, if you're quick with math, you may see that that doesn't add up to 540. But down here in the bottom right-hand corner, there is 4% of these projects that we're tracking are about 24%. We're not really sure yet because they're still in design, or maybe we just don't have that information available to us on what the height is. So that's where those numbers are, if you're wondering. All right, so let's talk a little bit about construction types. So just kind of get a little bit into the code specifics here, and then just a little bit about mass timber. If you're kind of new to that, where do you find those kind of things at in the code? So mass timber systems are defined in Chapter 2, and then you can also see some of the other different standards and information about it in Chapter 23, which is the wood chapter. And so basically, mass timber elements are allowed anywhere where we can use combustible materials, or sometimes you'll see the term heavy timber in the code as well. And so as long as we can, we're in that, then we're in good shape. And then looking at the actual construction types themselves, those of you that are familiar with them, you know that there's five, types 1 through types 5. Types 1 and 2 are generally reserved or considered to be non-combustible type construction types, but there are a few provisions and a few examples where we can use combustible materials like mass timber in these types 1 and 2 projects, specifically and most commonly in the roof assemblies of types 1B and anything that's type 2. One of the greatest examples of that most recently would be the new Portland, Oregon airport terminal. And there was also Portland, Maine's airport terminal is another great example of this as well. That was built a few years ago. So both of the big Portlands have really nice mass timber airports, and they both are type 1B projects. But generally, otherwise, where we see this being utilized is going to be in types 3, 5, and then type 4, which previously was referred to as just type 4, but I'll talk about here on the next slide where there's been some additions to that. And that's also something that is new to Michigan. Just earlier this year, they adopted the 2021 IBC. But so type 3 and type 5, those are two construction types. I really won't go too far into the detail of what those are for the sake of time, but be happy to expand upon anything that you see throughout this presentation, either in the Q&A session or feel free to reach out. This is a presentation that could be 2 hours long that's been necked down to 20 minutes. So we're definitely going to leave a lot out here. So apologize if you feel like I'm going too fast. But so looking here to those tall wood construction types, again, this is something that was introduced in the 2021 IBC. We do have a page on our website that's specific for tall wood that goes over all of the different states. I know we have folks from every, more than just Michigan that are on this call. And so on that website, we talk about all the different places that 2021 or even 2024 IBC provisions are recognized, and we're happy to engage with you on that as well if you have questions on that. But we can see here that in the 2021 Type 4A, B, and C were introduced, and those have different kind of requirements for each of those. So Type 4C, we can have all of the mass timber exposed, and then when we get into these types 4A and B, we start to have some non-combustible requirements to help protect the mass timber for fire protection purposes. But we can see really, really large buildings here that are available with this, right? Up to 18 stories and 270 feet with this Type 4A. All right, so fire design. This is always something that comes up. Sandra talked a little bit about this in her segment there. But really, where this really comes into play is that and ties specifically into those construction types is the construction types through table 601 really drive what the fire resistance ratings are. So how many hour of a rating do we need? So generally, when we're talking about these residential occupancies, we're always going to kind of have a 1 hour rating required, even if some of these columns say 0 somewhere. But maybe if you're looking at other occupancies, you could get away with potentially not needing to have a fire resistance rating. And another place where this fire resistant rating is really important is your grid spacing. And so as you can see here, generally a 5-ply CLT panel is required to meet these 1 or maybe 2 hour fire resistance ratings. And so if we jump down here, we can see what some of the different spans are available. So this is talking about our floor span range. So with a 5-ply, you can look at maybe getting about a 14, 15, maybe even 17 feet, even though I think that's maybe slightly pushing it from other factors, floor vibration, etc. And so these different things kind of all start to come into play. And again, these are all things that Woodworks, we love to engage with you, talk to you one-on-one about your specific projects and requirements. Just looking closely here, just really quickly, you can see down here the source. This is the 2018 IBC. It just has type 4. And then in 2021, with those new additions, you can see that the type 4 now has the A, B, and C requirements down here underneath that. So just added those in there, something you can refer back to check those out. But again, we've also got highlighted those construction types where mainly you'll see mass timber being utilized, which is that types 3, types 4, or type 5. So how do we actually achieve that fire resistance rating? So great, we know that we need an hour or 2 hours, but okay, well then what, right? How do we actually show that in reality? And so through the IBC, we've kind of got two paths. If we're in that type 4 HT, we can just utilize the minimum sizes, or we can demonstrate the fire resistance rating. And the way that we can demonstrate that, we have two options with that as well. So the first method is don't do a calculation, a char calculation. You may hear that referred to as sometimes, and that's going to be through this code path here, through the IBC, and then over into AWC's NDS document. And then another option could be to do a test in accordance to ASTM E119. And a lot of times that's referred to as a UL test, but there is other fire assembly or fire testing facilities that are out there that can do those types of tests as well. And we do have an inventory of those on our website. And then this would be an example of one of those resources that I was talking about at the very beginning. We do have a solution paper that goes into depth on this. And again, happy to talk through this as well. All right, so enough about all of that code mumbo jumbo, and now into the fun stuff, right? Into the case studies. Let's see some of this in action. We're kind of going to break this down into these three different components, and then we'll finish with some tall wood examples. So first, we'll talk about using mass timber floors and then with light frame or stick-built bearing walls. So basically your typical multi-family type construction, but we're just going to swap out I-joist, solid sawn, or floor trusses with mass timber elements. In the middle is something similar to like what Sandra was talking about with the stem building, post and beam construction. So we're just swapping out that steel frame for mass timber elements. And then lastly, load-bearing walls. Though not very common, this is an option as well, which is basically you're actually replacing the light frame walls with CLT elements or mass timber elements. And so just kind of starting again with this low rise, right? So this is going to be that 85 feet or below type height category. So starting with that hybrid, right? So here's just an example slide just to get us introduced to what we're talking about. So we can see in this instance, it's a CLT floor plate spanning across here. So you could totally leave this exposed, or in some instances, maybe you can still have a soffit, cover up your MEP, plumbing from above, etc. And I put down in the chat, and I need to, let me stop here for 1 second to of these projects here that I'll be going into, again, it'll be kind of rapid fire here. But if you want to look into any of these more in depth, you can go to this woodworksinnovationnetwork.org and check out these, just type in these names, and you can see more pictures, learn more about these projects specifically. But so here's this first one. This is in Sacramento, California. So you can see these light frame walls. This one was really unique in the sense that They utilized 12-foot high ceilings with these, so really tall studs for this project. They're able to um, to also make this at a market rate type rent levels as well. Another one, this one's down in Mississippi. We actually had a webinar that went further into depth on this project. We actually hear from the design team. If this project is of interest, happy to talk to you about this and also share that link to that. This particular project, because they wanted the CLT to span from these demising walls or to the outside walls, they actually had to bump this up to a kind of an uncommon amount of a 7-ply panel. But this helped them, give them really good flexibility on the inside. And they were able to complete this 30,000 square foot project in just 4 months. So a really rapid speed of construction here. And this was the phase two for this development, and it went so well they actually went ahead and continued in phase three by continuing to use mass timber. So a really cool project there. Another one is Cyrus in Denver. This one was a 7-story affordable housing development. It's a 5/2-story podium using Type 3A construction. So those exterior walls were your required FRT lumber for this. And though it doesn't show in the pictures, they even used a very unique ready core system for the stair tower, where that's those kind of pre-manufactured, kind of looks like a shipping container steel core that they set in and fill with concrete. And that's just again to help with that rapid construction that you're able to achieve with CLT. But this project was over 280,000 square feet, so quite a large project. The canyons, we have this project is was featured in one of our webinars as well back during COVID. This one uses light frame walls with CLT floor panels. It also had this really cool, unique kind of open air entryway here. So you can see these CLT panels making this kind of zigzag hallway. So a really cool feature. This also was really emphasized that this project needed to have 100% ADA accessibility for this, because this was more oriented towards senior living. And then we also do have a business case on this that goes into depth with all the different financials on this project as well. In the same webinar, we also talked about this project one in Oakland. Really cool 4-story project, 17,000 square feet. 17,000 square feet. Took them just 23 working days to install this from the ground up. And it saved them about 4 months on their construction schedule by switching to mass timber. You can also see the really tight project site that they had. They didn't have the ability to have a lot of stuff out here in the lane of traffic. So they were able to, pull these construction materials up on the truck and just lift them straight off the truck onto the project with the crane. So that they were really able to work with this tight site. No lay down area, and that mass timber really helped with that. Though not multifamily, this one's a hotel down in Texas, but this could easily be a studio apartment as well. But look at this really great aesthetics here with this space with these. This particular project used Dow laminated timber, or DLT. But look at that nice warmth of the wood versus maybe what this typically would have been built with is maybe a hollow core with that kind of popcorn finish on it. So really something that's a really stand out. So if you go down to Austin, maybe look at staying here. Another entity that you could do is you could build your multifamily the way that you normally would build it, but maybe look at swapping out the stair tower and elevator tower with just a CLT shaft or a mass timber shaft element. You can see here with this one, that member being dropped right into place. So this is another alternative, whether this shaft is built 1 floor at a time or whether it's built 2 or 3 floors at a time. That's something that we can help you kind of work out as well. Now, switching over to post and plate, just a few examples here for this. This particular project pictured here is really an office building, but this could be fitted out for multifamily as well. Here's one in New York. Kind of a smaller project, but this one was done with TNG decking as well. So this wasn't a cross-laminated timber, but TNG decking can definitely be used as well. This is one that is in Wisconsin, 7 stories, It's another 5/2, 5 levels of residential units, kind of more of a high end. But this particular one used glue laminated floor decks, which is basically just your glue lam beams laid on their side as a plank. And then you can see that this also was a steel hybrid. So a steel frame. So this still had steel columns and beams. It was just a mass timber floor assembly. Another option could be, again, as we talked in that very opening, is the mass timber bearing walls. So this is a picture from one of these Candlewood suites that the Department of Defense has been putting on some different installations. And here's an example, just from the outside at least, of the hotel at Fort Drum. And so these were ranging from 4 stories. I think the most recent one that was done in North Carolina is 5 or 6 stories. I don't recall exactly how many stories that one ended up being. But basically, it's just a platform frame. So CLT walls, they put the CLT floor, CLT walls, and then you can just build them up that way. So these projects are all mass timber from the foundations up. So the stair towers, floors, walls, everything. This one is a vertical addition example. So you had this existing 3-story building. And I believe this one, it doesn't say here on the slide, but I believe, or no, it looks like, or yeah, it does right here. It says it was is in Milwaukee. I was thinking this one was in New York City because there was one, it was either in New York or Boston that was very similar to this as well. But it's a 3-story existing building, and they're able to add 2 stories using mass timber because of its lightweight on top of it. So kind of increasing that density, also saving that historical fabric of the existing building and that history, but getting some more folks there. So also another example of this in Washington, you can see this project part is over here that mainly we're talking about. So we've got a 3-story existing building, and then they were able to add these 4 stories of mass timber on top of that. So different examples of this. There's also an example of one that's an office building in Washington, D.C. ADM project is another great example of this kind of vertical addition because of the lightweight nature of mass timber. And we also have switching categories here to tall multifamily. So this picture right here that we see is in Cleveland. This is the intro project. We'll have that one coming up here in a second. But kind of the first one in this realm was in Portland, Oregon, Carbon 12. This one is 85 feet tall and included 14 residential units, and really nice looking project there, as you can see. Really nice condo space with all that exposed mass timber, both not only just the ceilings, but also at those beams and columns. This one's out in Seattle, Washington, Heartwood. This one was actually an 8-story project, so this gets into those tall wood construction types, but this one was also designed and built for workforce housing. So starting to see some of those type projects be utilizing mass timber. Here's that intro project that is talked about on that opening slide, right there in Ohio City. So just across the Cuyahoga River from the baseball stadium. So a really great location. Also located on their light rail system line and across from their historic farmers market. This one's a really tall wood. This project in Oakland utilized glue lam, or I guess you could say mass ply columns and floor plates only. So this does not have any beams or girders. It's just post and plate type construction. And this one was featuring 6 stories of mass timber over a 2-story podium. So, like I said, getting really, really tall. Not as tall as Milwaukee, but still pretty tall. And then this one's up in Boston. This one is a passive house example. So there's a few of those other out there as well that are achieving those really high standards. Some of these, like that intro project that I mentioned, but intro achieved LEED Platinum. So a lot of these are achieving really great LEED standards as well. And this one has a really unique structural design by utilizing the unique aspect of cross-laminated timber having strength in the weak axis to eliminate beams in the hallway. Gives it a really nice, efficient design. And so that kind of wraps up all of those different case studies. And looking forward to here as I guess Sandra joins us back, answering any of the questions that may have come in.
Yeah, great. Thank you
Thanks for
so
having me.
much, Anthony. Let's dive into those questions. We got quite a bit of them, so that's great. It's going to be a great conversation. And before we do, just a reminder that yes, this session is being recorded. It will be posted in the next couple of days. You can either wait for that, check back, or you can go to our YouTube channel now at the link below, hit subscribe, ring the notification bell, and you'll get an instant update when it is available. For those of you watching this session on demand in the future, not right now, you can take your quiz with an 80% passing rate. You'll receive your continuing ed certificates. For those of you here live today, make sure you review our new CEU policy. As long as you've been here for the entire CEU approved hour, you should receive your Gutenberg cert straight to your inbox. If you've got the appropriate email and name written on your Zoom account, you will get that. And again, as we're waiting for those questions to come in, a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our almost 500 members. We're trying to get there by the end of the year for our 25th year anniversary. If you haven't yet, please support us, consider that. And our top tier sponsors who are helping decarbonize, make our homes more sustainable, like Ream with heat pump water heaters, Build Equinox with smart ventilation, Timber HP for decarbonized wood insulation, and others. Check them out and learn more. So I want to, speaking of decarbonization, embodied carbon, obviously, right? That's the kind of the thing that's kind of the thing that we're kind of focused on with the benefits here. So life cycle analysis, LCA, whatever you want to say it. Some of these questions came in. Let's address them. Um, and I think one starting at the start of it, what from an embodied carbon standpoint, you went into a little bit of that, Sandra, but sort of one question came up is maybe on the single family side, kind of how it's comparing, or even low-rise multifamily where there really is less concrete, how this is comparing to just your traditional wood structure. Does it really have a benefit there, from the embodied carbon standpoint? And then another thing I'll add is, um, are these products getting environmental product declarations so we kind of have that data?
Um, well, it's a little bit of that's a kind of a hard way to answer the question. First, with the EPDs here, I'll say some mass timber manufacturers do have environmental product declarations, and some don't yet. I think that's right, Anthony. I know they don't all have it yet, but many do. So, want something to look out for when you're in your procurement process. In terms of comparing against stick frame or other typologies, most of the analyses and the comparisons are happening against comparable commercial construction types as opposed to stick frame. Although if Anthony, if you ask a question that Anthony can answer, I can pull in a link that would help to compare a building that was a multi-family, multi-story building that was um, a wood frame building, and then they compared what it would have been if it had been a mass timber building, both across cost and carbon. So I'll pull that up while Anthony's talking to a different type of question, and then share that in the chat.
Okay, great. And Anthony, I mean, do you have anything on the sort of embodied side to add to that, or happy to hear from you too?
Yeah, not specific, other than I'll just say that we do have a carbon section on our website.
Okay.
I shouldn't say a carbon section, but we do have EPDs listed on there. I believe it's
Oh,
considered an expert tip, but we do have a place on there where you can find
yeah,
all of the EPDs, at least that we're tracking for the
right.
different engineered wood products.
Perfect. And so on the other end, the question that came in is, of course, we're always thinking about what we do with our buildings and our products at the end of their life. Now, hopefully these buildings are here for, 200, 300, 1,000 years, and we don't have to worry about it. But, it doesn't always work out that way. So how, are there any plans or what could potentially be done with these mass timbers, these CLT products at the end of their life?
Yeah, so I answered this question in the Q&A rather extensively, but
Mm.
the deal is this, you know, we are really bad at, as humans, as rolling out a new typology of anything and thinking about what happens at the end of life, which is why we have
Yeah.
batteries and all kinds
Right.
of waste stacked up all over the place.
Right.
However, it is important that we do this, and it is important that we do it early and often. And so with mass timber, there are quite a few people who, in academic institutions, professional settings around the world, that are interested in this question, including folks here at MSU, in looking at, yeah, when building one is done being building one, what happens with the mass timber materials, and can they go into building two, and how do we facilitate that? Of course, making turning buildings into future feedstock warehouses, which is kind of what we're asking of this system,
Mhm.
is super complicated, it turns out. So
Mhm.
there's a lot of work and planning that needs to be done to figure that out. But from a technical perspective,
Mhm.
there's no reason why mass timber materials of today couldn't be turned into new mass timber buildings in the future. Um, it would require designing and cutting and reformatting the whole kit of parts, and that is all a thing that could happen. But it's certainly worth doing. It's something that's very important. I also would say that I think it's important to be thinking about move in the future. Um, how can we create mass timber materials that are biodegradable or could be easily processed into something else if it's not mass timber? And that means probably, although who knows what will happen with technologies in the future, we could be able to easily process something that has a fossil fuel based adhesive in it in the future. We can't do it right now, but it would
Right.
be great to have biodegradable adhesives, which is something that Michigan State University's Department of Forestry professor Mojgan Nejad has been working on, making adhesives and coatings for mass timber that are made from lignin instead of fossil fuel
Mhm.
based polyo. So a very exciting technology that would create a completely biodegradable product.
So let's talk about the structure, the wall assembly. One question that came in was about the use of these on both the exterior and the foundation or under slab.
Yeah, I think so. CLT is not something that's rated for exterior construction, but there are options for pressure treating of glue lams.
Mhm.
So that's sometimes something that can be looked at for exterior. We can also get you in touch with manufacturers of different high-end coatings as well that can allow a non-pressure treated element be, and again, being something like a glue lam being exposed to the exterior. Now, uniquely, that Magdalena hotel project that I talked about, you can maybe notice that in those in that one picture from that slide, but that one does include exterior breezeways, and that was constructed with DLT. So if something like that was maybe of interest, to my understanding, they slightly put gaps in between the members of the DLT to allow the water to go through. But if something like that would be of interest, happy to talk more in detail about what exactly you're trying to achieve in your specific application, because it's probably something that's going to be more on a case by case basis than saying, use this standard detail and you're all
Yeah.
set. So
Um,
happy to dive into that.
okay. And from like a insulation standpoint, and of course, reducing operational embodied carbon, are these typically getting some kind of exterior rigid insulation on the outside? Is that typically how you're insulating these walls?
Yeah, I don't think generally from an envelope standpoint, I think what's holding the building up generally doesn't matter. I think you would handle the facade, the building envelope the same as any other building. Energy code type things would all still apply. So
Okay.
that's correct. Yeah, usually the exterior
Wouldn't be any
walls
different or yeah.
still cold form studs,
Yeah.
or EFIS or brick or whatever it may be, continuous insulation, per whatever kind of climate zone that you're in and what it's required on how much how much you're required in cavity versus continuous on the exterior.
Sure.
And we do have some standard details for those kind of things when it comes to how some of these components go together. But happy to again talk about those one-on-one type situations, what you're looking at for your project,
Yeah.
and its given region that it's in on a case-by-case basis as well.
Yeah. And speaking of that, one of the questions that came in, because, Woodworks, clearly you all have this awesome library of resources out there. So one of them was specific to whether you have kind of ready-made designs and specifications that people can use to kind of give them a starting place or.
Yes, we do have a specification for a few different categories available. I don't recall off the top of my head if that's something that you have to reach out for, and then I'll send you a note on, or whether that's just right on our website and you can go and pull that down. I don't remember if that's the case on the specifications, but on the CAD and Revit details.
Yeah.
We do have an inventory of those, not only just for mass timber, we also have a light frame section as well.
Yeah. Yeah.
Yeah.
Well, let's talk about some of the details here. Michael, I see your question. I don't know if it's going to need more than that. But the question specifically was lateral on the post and beam.
Well, I can maybe just how I interpret that at
Yeah.
least is on the yeah. So all kinds of different lateral systems you can utilize. You can use, for example, the most common on the tall wood type projects is still going to be your concrete core, concrete shear wall type situation. That was the case on that Webster project I showed. That was the case on the Ascent project. That was the case on Intro as well. So most of the time, that's how that's being handled. There has just a few summers ago was some testing on a new type of CLT rocking wall that was done as well. So maybe here in the future, and I believe there is one project that's under construction right now that's utilized or will be utilizing that. But for now, it's generally just your something you're very familiar with, concrete shear walls. There are new provisions in the latest code for CLT shear walls, so you could be utilizing the CLT panels for that lateral masonry walls, light frame shear walls could be an option as well. So in those multifamily light frame load bearing walls, it'd be shear walls like you're normally used to as well for that. You're just replacing that floor element to a different component. But everything else is very similar. But we do have a diaphragm design guide as well, looking at a different lateral element, more in the horizontal realm, and we can also connect you with different manufacturers of different straps and screws and all that to tie all those things together as well, because there's all kinds of different options in that space as well. Gets into the whole thing of tools and installation, so that you're not, bending over a lot. A lot of fastener manufacturers now have kind of specialized tools to help you be able to stand upright and install those fasteners more ergonomically. But
Uh,
and then also I'll just also finish that steel brace frames, moment frames are also common as well. Those can be just integrated within the glulam frame, or it could be maybe a normal steel frame building and it just has a mass timber floor. And in fact, AISC has a design guide that talks about that goes specifically into mass timber floors on a steel frame. I believe it's design guide 28. And there is presentations that AISC's done about that at past steel conferences. So there is information on that floating around out there as well.
yeah. One question was about the CLT floors being modified for MEP. Are chases or accesses built in already, or do they have to be requested?
Yeah, that's something that's generally coordinated ahead of time with the manufacturer.
Mhm.
So the manufacturer then coordinates with the design team, and they can either, if it's a big square, have that cut out of the CLT panel, or if it's holes, generally it's a certain size hole is determined with the manufacturer, that sizes under this they won't install, but holes, bigger than this diameter they will. And so this will help in that installation out in the field so that they're already there. You can imagine if, say you have a 6-inch roof drain that's coming down through the building, it'd be quite difficult through a CLT panel that's maybe 7 ply, trying to core a hole that's big enough for that pipe to fit through is quite a challenge. So if they can do that in the manufacturing facility with a CNC machine, A, it's going to be that much more accurate, but B, it's going to be that much more quicker to do.
Yeah.
I think the
But yeah.
second part of that question was, but what can you modify it once it's in the field if you need to make a change in the future, or
Yeah.
if you change your mind when you're doing the install?
Yeah.
Yeah, I'd say that that's something that would be obviously handled on a case by case basis, and that would be the same as if it was concrete over a metal deck. You would handle it the same way, depending on where you're trying to put it, how big of a hole you're trying to cut it. Do we have to add a supplemental frame of glulam beams around that to support maybe some edges of CLT, depending again, right where it's at. Is it in the middle of a big span or how big it is? But generally, the holes, again, with the manufacturer, even if those are added later, we're talking round holes, for a 2-inch conduit or something. Those can be kind of just worked out on that case by case by the manufacturer. But
Yeah.
as a structural engineer, we always get nervous, right? And when we see the big long line of conduits that the wood bees have bored out, and you end up with a whole big strip of your diaphragm removed.
Yeah.
So still, those same kind of concerns that you would have with a concrete deck in some instances would apply to this as well. But
Yeah. Um, Sandra, I want to kind of bring you into this question and obviously when we talk about increasing sustainability, you potentially talk about increased costs, right? Or changing something where there's uncertainty about the cost. Now through the state of Michigan, it looks like there's some sort of bridge funding that's helping with these projects, maybe to shift over to this, this type of material, which is great. So I think, just, if someone's taking the traditional approach and they're trying to do this, can you speak a little bit to, what the cost differences are, or how to account for that?
Yeah, I can't speak to what the cost differences are because it depends on it's a
Right.
totally case by case
Yep.
difference.
Yeah.
However, one thing that is important to note is that when we are estimating a mass timber, and it's changing a lot. So somebody just said I linked to a study, probably the one I did in 2018. Oh my gosh, things are changing so much. So
Yeah.
and they're changing like today because there's tariffs. It's like it's just changing all the time,
Yeah.
right?
Yeah.
And are there tariffs right now? Who knows? But so one thing that's really important to note is that estimating a mass timber project is different from estimating a comparable steel and concrete project, especially right now, and especially because mass
Yeah.
timber systems are kits of parts and they're custom. So they are not, the mass timber system is not in your cost estimating software. So if you're somebody who's like, boy, I really want to make a mass timber project, do not hand your project off to an inexperienced estimator and expect them to know what to do. They need to call multiple mass timber manufacturers and speak with them directly. They need to be prepared to work with those manufacturers on a design assist basis to ensure that that manufacturer knows how to optimize their material specifically for the design that you're trying to execute. That cost manufacturer needs to know that on the construction side, it is very likely that the building will go up significantly faster if it's mass timber than it's steel or concrete, and they need to know how to account for those efficiencies in their estimate, and they need to know to account for not needing to put as much fire coating on the material, not needing to put as many aesthetic finishes on there. And if I'm a cost estimator who's never done one of these before, I don't believe you when you tell me that I'm going to achieve those cost savings until I ground truth it for myself. So there's a lot of education that needs to happen for that cost estimator, and resources that cost estimator needs to be provided. But when we see people taking those steps, what we're seeing is that mass timber is generally coming out much closer to steel or concrete. Sometimes the mass timber is coming out better. We've started to hear that even the materials costs right now in this current environment have sometimes been lower than steel or concrete because of tariffs. So you really have to do your legwork to get if you're like, I want a mass timber project, don't let them value engineer it out because they don't know how to do the estimate, is what I would say. And Anthony, I know that Woodworks has some good presentations about how to approach the cost estimate. So if you want to either point people to those or add, we'd be happy to hear it.
Yeah. In fact, that was a small section of this larger presentation that I didn't get into, but we do have information that helps you look at costs. We don't have specific cost data in regards to it's $10 a square foot or $25 a square foot or whatever it may be.
Yeah.
But we do have two resources that are available, cost kind of estimating checklists, and then we also have another guide that kind of talks about things that impact cost. A
Yeah.
lot of the ones like Sandra was just mentioning. Just
Yeah.
to make sure that all those different things are accounted for, because a lot of times what that common mistake is it's just kind of looked at as a line item swap out. Okay, I've got my steel
Yeah.
frame from my steel supplier. I'm going to delete that and then put in what the mass timber manufacturer is giving me.
Right.
And if that's the case, then you are going to find that it's a significant potential increase because that glue lam, CLT, etc., probably per element is going to be more expensive than the steel element. But we have to look holistically at all these other different things. Is MEP install going to be faster? Is finish is going to be faster? Are we removing a step of painting stuff or
Mhm.
removing a step of spray on fireproofing or drywall or whatever it may be? What are the
Right.
savings for that? And then also something maybe as small as the general conditions. Done with my project 4 months faster, not paying for fences, dumpsters, job site trailers, etc. for those 4 months. And my owner or my client is in the project 4 months faster, charging rent, using the facility, not paying rent somewhere else, etc. And so all of those different things have to be taken into account. And so it gets to be a lot more complicated than just comparing,
Yeah.
how much it was for one material versus another.
Someday maybe we'll have mass timber widgets.
Yeah.
Well, on that note, do you have a second for another question?
Yeah.
Yeah. So I'm thinking, of course, we're moving towards a prefabricated, a modular construction, hopefully, right? That's where I think we're heading. A lot of the benefits you're talking about here are the same talking points that the modular manufacturers talk. So is it that something like this just gets appended into the modular manufacturing process? So really, this is just going to the modular plant and then they're bringing you the mass timber unit. Is that kind of where we're headed?
Hmm.
I think that will happen for parts of the market over time. There's like there are so many people who are like, well, obviously mass timber and modular together.
Right.
Yes, I think for part of the market that's true. I think mass timber continues to be an awesome option for buildings that are not modular because of the
Right.
beautiful
Mm.
the ability to create beautiful, innovative, organic designs. I think there's all different types of market niches for mass timber, and certainly modular is one that has a high potential to try to solve for a lot of different problems.
Any other thoughts on that, Anthony?
Yeah, I would agree. We do have some information that's an area that we're increasing the amount of information that we have.
Yeah.
But we do have some information on modular. It's something that here right now I don't have a whole lot to say about it specifically, but we do, on our website have resources regarding it.
Yeah, great. Well, we are at our time. Just so I know you've all been great in mentioning where to find things, but just as a last minute reminder again, Sandra, where can people go to learn more about you and any resources they can get from MSU on this?
Yeah, our website, which I'll type into the chat, is masstimber.msu.edu. And my email, lupiensa@msu.edu, both which I'll add to the chat.
All right, and Anthony.
Yeah. I just put in woodworks.org into the chat, and then I previously put my email in there, but it's anthony.harvey@woodworks.org. But yeah.
Yeah. All right. Well, Sandra, Anthony, thank you so much. Thanks to, of course, Michigan State University and Woodworks as well, for joining us. Thank you all for attending. We are going to wrap up now, but we will be here again, same time, same place next week for our webinar series. So take care, all. Be well. Thank you so much.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.